Hi everyone. So in the first part of the second lab, what we have seen is how to download enhanced dataset into your computer using R. And at the end of the part 1, we have saved the dataset for later use. So we are going to use this particular dataset that we have already saved in our part 2 of this lab. So let me just work with the knitted version where I just check by my getwd where is my working directory, and then I load the exactly same dataset that I saved at the end of the previous lab part. Alright, so I use the ls command to see what is the object that is saved in this dataset. The object name is Analytic data, and this is basically a data frame that we have saved in our previous part. So I just check the names of the variables, and the name of the variable is like this. I check the summary of the diastolic blood pressure, and the summary is like this. Okay. So before we work more on this dataset to create an analytic data, let us first look back and try to take a look at each single variable. Marital status in 2013, and that is in the demographic information. And let me take a look at the document where I have some marital status, and in that marital status you can see what is the target population based on which this survey was conducted. You can see both males and females were there. The age group was between 20 to 150, whereas if you go to, say for example, gender, the target group was from 0 to 50. So there is a mismatch between the targets. So it is always a very good idea to study which particular variable is coming up with which particular targets. So I have listed all of these variables that I have in this particular dataset, and I have also collected all of the targets from these variable descriptions, and I have listed them here, and you can see the common part is from 20 to 50 years or 150 years of age. So we will use this information later. So at first I have this systolic blood pressure from 66 to 228, and this diastolic blood pressure from 0 to 122. 0 diastolic blood pressure, is that an implausible value? So if that is the case, that this 0 value is an implausible value, then probably that is that should be reassigned as a missing value. So that is what we are doing here. We are changing all of the 0 values to not available values. So we are using the record function to change the 0 value to any values. We are creating a new variable blood pressure to save that variable, and then we are deleting the old variable for the diastolic blood pressure. So for the diastolic blood pressure, now the minimum is 4 and the maximum is again 122, just like before. We didn't change that part. So in terms of race, there were a number of categories of race. I have decided to include all of these categories into one category. Part of the reason we want to do is, if in some categories the frequencies are low, then you might want to combine some of these categories. Again, I'm saving this as the new variable res, deleting the old variable, and I'm checking the tabulated values. And notice that I'm using use NA equals always. So that means that if there was any missing values here, then it would be represented here. But even if there is no missing value, it will confirm you that there is no missing value in this particular variable if you are using this use n equals always. Alright, so we have this age variable. The age can vary between 0 to 80, and here what I'm doing is that I'm trying to find out the age of the people who are at least 20 years of age or more, and if there was any missing value, remove those missing value to find me that mean value, and that mean value is around 49. This is not really the actual mean age. To understand why that is the case, I want you to go back to the data dictionary in the NHANES and try to figure out why the mean that I have calculated is not the correct mean. And from reviewing that, you should be able to figure out why this is not the correct mean. Alright. So let's just go ahead with it and say this is the mean, and I'm just deleting the mean value from the age variable, and that should give me a centered value. So the centered value is now between minus 49 to plus 30. For gender, I'm checking the male and female category. There is no missing value. For marital status, there are many categories, and so I am using I'm combining some of these categories to previous married, and some of these categories to married, and one category to never married, and whatever else we have, such as refused, don't know, and things like that, I want to assign them as not available. So whatever else that I have not described here will be assigned a missing value in this. And then when you check these, you can see only you have this married, never married, and previous married, and missing values. For the alcohol category, you can see there is a 999. So what does that mean? This almost 1000 drinks. That seems implausible, but if you go back to the data dictionary for alcohol, say for example we are dealing with this particular variable, and I want to go to the ALQ. I just remembered this, and I'm searching for this variable, and you can see this 777 is refused and 999 is don't know. So we need to recategorize those values, and values 1 to 25 are actual values, average number of alcoholic drinks per day. So we are assigning not available values to the 999 values and not available values to 777 values, and then when I tabulate it, I see there are no 777 or 999 values anymore. Alright, so that is also the case for smoking variables. So this is our smoking variable that we have chose, and if we go to the smoking and find the variable, you will see the smoking variable has 7 as refused and 9 as don't know, right? So in that case, I'm reassigning missing values for values that are equal to 9 or 7. The way they are describing here, I'm just assigning missing values, and when I tabulate them using the use NA, I can see there are some missing values here. So previously you have seen I have renamed the variable by creating a new variable smoke and then deleting the old variable, and that is a bit cumbersome. If you want to take care of a large number of renaming in a variable, first print the names of that dataset's columns or variables, and then in the same order, say for example SEQN is basically the ID, and in the same order just put the new names, whatever names you think are easy for you to remember, because you do not always want to go back to the data and try to see or try to remember what was the exact name of a variable. Instead of this, if you simply have a variable such as smoke, that is much easier to remember for yourself, and that is something you should probably do as well. Alright, remember at the beginning we were talking about the targets, where the marital status variable, the target of it was from 20 to 150 years of age. So in that case, we are categorizing our age variable from -infinity to 20, 20 to 50, and 50 to plus infinity, and I'm assigning right equals false. So that means that the categorizations will be just like this. There is a 20 cut point, there is a 50 cut point, and there is something in between. So for the alcohol variable, we had the target age from 18 to 150, but for the marital status variable we had the target from 20 to 150. So if you just simply tabulate the age category with the marital status variable, you will see that in this -infinity or 0 to 20 category there are no cell counts for obvious reasons, because the data was not collected for marital status for those who were less than 20 years of age. So if we go ahead with this analysis, then we will face a lot of trouble because of the zero cell count issue. So one of the things we should do is we should get rid of the age that are less than 20 and keep only the subjects who had age greater than or at least equal to 20. So this is doing two operations at once. If there was any missing age, I don't want them. I want the available age only, and I want those with age at least 20 or more, and I subset the data. Later we will show why subsetting the data in this way is a problematic idea, especially when we are dealing with survey data analysis. So for now we will just go ahead and do this kind of subsetting, but for later we will do a very different kind of subsetting for our survey data analysis. So we have created a dataset without any potential zero cell issues, and we have recorded the dataset the way we want, right? Save this dataset again in the working directory, and then I try to do some basic regression summary. So one of the problem of doing this kind of regression summary is that I still have some missing values, and when I'm running this GLM function to run a linear regression, what is happening is that it is automatically deleting the rows associated with any missing values, and it is working with only the complete case analysis. So I just for trying out, I just run this regression and I see the beta coefficient for this diastolic outcome. For the diastolic, I also run it on marital. I try to see how the data looks like. You can see the age category is a factor variable, smoke is a factor variable, alcohol is an integer variable, and so on. So str is a nice way of checking your dataset whether you have any issues with the dataset. And of course it is possible to run a full regression with all of the predictors that you have, and this is giving you the coefficients, even though in a predictive model the coefficients are not that important. But we did know that there are some missing data issues in this particular analytic data. One way to assess this missing data in a very easy process is just to use this plot underscore missing command under the data explorer package, and you can see the smoking has 56% of missing, the alcohol has 40% missing, diastolic and systolic has about 11% of missing, right? So we use the create table 1 function from the table 1 package to create a table 1, and we can see the general table 1 for these variables. It is often a good idea to make sure that you have the correct variable types. Say for example, the systolic blood pressure should be a numeric variable, and I just checked that that is the correct form. But sometimes when you are running this table 1 package, if you do not have the variables in a correct form, that will create a lot of trouble, and the table will not be viewable in a correct form. So say for example, in case you are expecting a numeric variable, but your numeric variable somehow got converted into a categorical variable while you were doing categorization and all that. So sometimes that can happen. So if this was a numeric variable, but you are when you are checking the mode, you can see this is converted to a character variable. An easy way is to use the as numeric as character command, and that will easily convert them to a numeric variable again. So you can do that one by one, but there is a easy solution for you to convert them together. Say for example, the systolic, diastolic, age-centered and alcohol are numeric variables, and all of the rest of the variables are factor variables such as smoke, race, gender and marital status, right? So you can simply use this apply function and specify the which of these are factor names and which of these are numeric names, and that will automatically convert it in the correct format. Again, this is only necessary when you see your variable is not in the correct format. Alright, so I have printed out the table 1 here, but this time what I have done is that I have included NA values. So if there was any not available or missing values, I want the table 1 to print them out. So I see that there are some missing values here, and one easy solution could be, and obviously a wrong solution, if your data doesn't follow certain assumptions, is that we can delete the observations that are associated with any missing values. So we can obviously do that using the NA omit, and then when we create the table 1 and ask it to print out the NA values, see there are no not available values here anymore. And we can fit a regression model using this complete case data, and using the publish package you can see the various coefficients and confidence interval of this regression. Even though for a predictive model these coefficients are not that important, but I just wanted to make a point about what happens when you make the complete case analysis. So other than complete case analysis, when you are missing some data, what can we do? We cannot really go back to the field and collect the data. In that case, what we generally do is we use an imputation method. There are different imputation methods such as multiple imputation, a number of ad hoc imputation or single imputation methods. So in here I am simply going to use a simple imputation method where if a number of variable values are missing, I'm simply going to sample from the same variable to impute those values. Obviously this is an ad hoc method, and later in this course we will learn more about proper missing data analysis. So when we do this, when we impute the data using this mice function from the mice package, we simply extract the complete data set after imputation, and we can see there is no missing values in here anymore. And we can do the create table 1 again with include n equals true, and there are no missing values here anymore. In here you can see I'm again fitting the regression predictive model, and I'm again getting the coefficient, and you can see the coefficient values are not very different when you are comparing the coefficients, and see some values are slightly different, but I would not say the values are very different. So here is a function called plot sums from the JTools package, and in here you can see even though their estimates are, and even also the confidence intervals are decreasing. So this is model 2. Obviously when you are inputting data you are working with more data, that's why your confidence interval is decreasing the width, but your point estimate, if you look at your point estimates are sort of in the same direction of the graph of this zero null value, with some exceptions. Say for example some of the smoking values are going on the other direction. The one category in the previously married is also going in the other direction. So this is problematic. So whenever you are seeing after imputing and before imputing values are different, that is hard to justify. In that case it is generally hard to justify the complete case analysis. But the good news is for us, we simply use a sample imputation in here. So we used a method of randomly sampling to impute the data set. So if we do the imputation again, the results might not be the same anymore. So I mean, obviously there is not much to gain by doing this kind of imputation, but I simply wanted to show what happens if you impute the data in terms of the width of the confidence interval. So later in the course we will learn more about this, but for now this is the lab for today. Thank you.